That'll wipe. It's awesome.
All right, this here is our OmniTurn GT75. We bought this a couple of years ago now. Believe it or not, we bought it for $2,400. It had some damage to it. The control, somebody, I don't know, ran a forklift tine through it or something. But it only cost us about $1,000 to fix it. And we've been running it for 2 years now, haven't had a single problem with it. It just illustrates when it comes to used CNC equipment and you're on a budget, I believe it's worth it to take risks. I think that's part of succeeding. You can't afford new machines, so you got to take risks. Make calculated risks, but it's definitely worth it. You can get a lot of bang for your buck on a used machine. This is a gang turn lathe. Right now I got it set up for collet. You can put a chuck on it, but once you use a collet, you realize it's so much quicker, more precise than using a 3-jaw chuck. Usually, if you're doing multiple small parts, a collet is the better way to go. This has got interchangeable ones too, and they come in different sizes. You can kind of see, like, this is a bigger, like 3-inch. So this is a 5C spindle nose, but it's a hard-inch style. It's a taper style, taper lock, so you can put these bigger collets on it. You can go all the way down to the tiniest of 5Cs, all the way up to these bigger step ones for bigger work holding. As I think I mentioned before, we paid $2,400 for this, plus we put another $1,000 into fixing it. I've also seen a lot of examples, used ones, anywhere from, like I say, a couple grand up to 20,000, and a whole bunch in between. Several for like 6, 7, 8,000. They also make an attachment version of this that attaches onto old hard-inch lathes and turns them into CNCs. Those you can get even cheaper. I've seen those. We bought one for $1,000. I'll show you that here in a little bit. But compared to a Tormach, just their base machine starts at right around $15,000. And with automatic collet, because it comes with the Tormach comes with a manual collet, you know, that's like a $3,000 option, and the enclosure is a $3,000 option, and it doesn't have servos like this. It has steppers, and it doesn't, I believe it doesn't run on linear ways. It's just some sort of dovetail. This has class 7 angular contact bearings. Total indicated run out on these, they even publish these specs, are 0.00002. You know, the Tormach will never make that. I doubt it even has class 7 bearings. This too, also, we kind of look at the heart of this that makes this machine so accurate. I get into a little more detail later about the specifics, but you can see under here, you can see this is the main casting here. I don't know if you can see that there, but I mean, that's like, it's solid. It's a solid, good solid 4 inches. And the linear ways, they're a little pocket machined right into it, fits right into it. The headstock cast iron, and that also bolts directly to this 4-inch thick base casting. You got precision ground ball screws, they're NSKs. The linear ways, they are either German Rexroths or Japanese, like NSKs too. You can see this here. I don't know if you can read that, but you can see it's a German. Super accurate. This machine will hold the accuracy. They list the accuracy at 0.0001. repeatability at 0.00005. So I mean, it too, I find it'll hold tenths of a thousandths all day. Super accurate. People who have the Tormach, testimonials on that, I've heard people say that their Tormach, even in between parts, can sometimes vary a thou or two, which just isn't acceptable if you're going to run production work. This machine is literally 10 times more accurate than the Tormach, and it's not an exaggeration. You can make aerospace quality parts on this and hold tolerances. You don't have to chase it around. Yeah, like I said, this does run on servos too. It's not steppers, they're full encoder. Trying to think of stuff. The rapids, you know, I get into these details a little more, but the rapids on this, 300 inch per minute cutting and rapids. The Tormach has 60 inches per minute cutting and 100 inches per minute rapids. So this is 3 times as fast. It doesn't, you know, rapids is everything. The difference between 100 inch rapids and 300 inch rapids is significant. Call up some videos of a Tormach cutting and rapiding. It's like watching paint grow. This machine is really fast, extremely accurate. Let's think that's all I have to say about this. I have some more I say later in the video, but that's just kind of a quick overview. Like I said, you can get these for, you know, under 10 grand. A Tormach similarly equipped is going to run you around 25,000. Used machines are still getting in there, and they're beat to death. We've had this 2 years, and this enclosure looks, well, it's a little dirty now, but it looks like the day we bought it. And this is a 10-year-old machine already, and we haven't had in 2 years a single problem with it, and we run it all the time. So, you know, it truly is it's not, I'm not trying to trash the Tormach, but for the same or less money, literally thousands less, you can get a professional grade machine that'll make, yeah, it won't hog like a big Morisaki, I realize that. You know, keep your parts, you can put up to a 5-inch chuck on that. Biggest part I've ever machined was 5 inches in diameter. So, you know, keep your parts reasonable. The truth is, the reality is, though, if you're in machining, you kind of think, well, I need something that'll handle something really huge. Well, you'll find 99% of your machining is a few inches, around a few inches in diameter. Let's go take a look at that, an attachment. We got a 2 attachment OmniTurns. Okay, this is an old, well, the lathe itself is like a 1980. It's a hard-hinge lathe. And this is 5 horsepower. It's got a coolant tank, but it has what's called an OmniTurn attachment. And what this attachment does, like our other machine, it too is uses a rigid base plate, only this one bolts to the actual bed, the original bed. You take the carriage off the hard-hinge lathe, and this bolts to the bed. But it's got the ground ball screws and the, you know, the good Rexroth or NSK linear ways, all the good stuff. These hard-hinge lathes are so incredibly, the tolerance on them is one of the most precise lathes in the world. So it has a control very similar to our other one. This is an older one. This is around a year 2000, but it all works pretty much the same. This one's got an air collet on it. But this machine here, we do got to build an enclosure for it, though. We've just been machining dry with it, not with the coolant. But we paid $1,000 for this, and I think we only, he said the control was being a little buggy, and we replaced the motherboard for 45 bucks, and it works great. So we got about $1,050 in this CNC lathe. It's not quite as rigid as the OmniTurn full enclosure one, because this does just bolt on. You can also see the base plate, little, not quite as thick, but it's still a great machine, just as accurate. All your programs can transfer over. So if you see one of these, you can get ultra cheap. You want to get into CNC machining, you know, take a risk on these. OmniTurn's still in business too, so you can get parts for this if anything's bad. This too, servos on each side. It's got all the good stuff. So yeah, the specs on this are really precise. The tolerances it holds, the run out, the backlash, all that. OmniTurn publishes all those specs too. They tell you what the run out is, what the backlash is, what the repeatability is. Tormach doesn't give you any of that information, which I think says a lot. So yeah, I love this machine. You know, it's a great small machine. Compact, can run on 1-phase or 3-phase. Yeah, get one. Oh, I should say another really important thing is the rapids on this. This OmniTurn has 300 inch per minute rapids, whereas the Tormach only has 60 inch per minutes. The RPM, this goes up to 4,000 RPM. You can go as low as 5, 10 RPM on this. It'll actually go that. Some of these came optional with a 5,000 RPM spindle. The Tormach goes from 100 RPM to 3,500 RPM. So this is faster, and the rapids are what, about 5 times, yeah, 5 times this machine's 5 times as fast in the rapids, which you may think at first, if you're new to machining, oh, I don't mind waiting a little slower, isn't a big deal. Trust me, once you get some experience, rapids are everything. You can watch paint dry with slow rapids. You want a fast machine, even if you're not doing high production. It's high production runs. It's still awesome to have. So you can rigid tap with this. You can program in either inch per minute or inch per revolution. So you can rigid tap with this. You can see right now I got a big rigid tap on here. It's a 3/4 12 tap. If you do real small teeny taps, you can get what's called a tap release holder. It just goes in here. It's a little spring-loaded device. They're like, I don't know, I think they're about 80 bucks. Because little taps, sometimes when you tap in and you go to back out, well, the spindle's got to stop and reverse real quickly, and sometimes on little tiny taps they can break. But if you get those little tap release holders for your taps, they're a little spring loaded, they'll go in your ER32 holder and they'll just release as it backs out so that there's no pressure on the tap, so you won't break taps. There's a little open and close button here, so you can close it, open it, take it out, put it back in, close it. This just comes standard, the pneumatic collet closer. It's adjustable, the pressure on it. Whereas on the Tormach, it's got a manual collet closer. If you want to get the air operated one, it's a $2,500 option, where it's just standard on the OmniTurn. The OmniTurn on the control, it's pretty much standard G-code. It's their own proprietary one, but it's very similar. I've run Haas's in the past. It's very, very similar. Like, we can go in, there's some of the G-code there. I don't know if that's showing up on the camera or not, but I've even read that Haas programs actually work on here. You just need to change a little bit. So if you have some sort of CAD cam that's outputting a post for you, you can do Haas ones, and you just need to tweak a few things on them. But it's standard, pretty much standard G-code. It's got lots of can cycles for threading and turning cycles and arcs, and it'll turn anything you want. These are also available with a C-axis, which will position the spindle, and you can put live tooling on this plate. Then you can do like engraving, offset mill. You can mill from the side or from the face. You can also do engraving, whatnot, if you get the C-axis. In the back here, this panel here is actually removable. This is, I should say the side. This panel here is removable. Let me take that off for you. Okay, here's the motor. That is a 5 horsepower motor. It does have an encoder right on it too. Here's the pneumatic collet closer. The Tormach has a 3 horsepower motor, and I think it's a Chinese motor too, the Tormach, so I'm not even so sure it develops the claimed 3 horse. This is a 5 horse. This will run on 3-phase or single phase, so you can, you know, hook it up to a regular household current. The entire lathe weighs about 1,650 pounds, which is comparable to the Tormach in weight. Electronics cabinet. This has the VFD in it. Also has the relays. We got some fuses in here, a little transformer. These all use Yaskawa Japanese VFDs, so you get really accurate RPM control, really fast acceleration and deacceleration. This will go from 0 to 4,000 RPM in under a second, so it's super fast. It'll also slow down just as fast because it is a toothed belt drive on there, so there's no slip. This does come obviously standard with this enclosure, whereas the Tormach, the enclosure, I believe, I forget what the price is. Yeah, the enclosure, if you want to get an enclosure on the Tormach, that's an additional $2,800, whereas this just comes standard with an enclosure. We got a chip tray down here, and the chip tray is removable. Just open this up. Here's underneath here, here's the chip tray, it just slides out. Usually get a couple of those, like have one for aluminum, one for Delrin, one for steel, have separate ones. This is the coolant tank. I don't know if you can see this, a little dark in here. Open this up a little bit, but this is the pump right here, so you can get access to pump to clean it. This holds about 20 gallons of coolant. Then we got this is the adjustable collet closer. That's where you can do the pressure of it. You can see there's some little just guides to what things do. Oh, I should say the OmniTurn 2, all that's user serviceable. OmniTurn's still in business. They're a U.S. company, U.S. made. Most of the components on here are all U.S. So you can get, you know, even like if your spindle bearings are to go out, you can get them. If you need new linear ways, new servo motors, new motion cards or motherboards or drivers for your control, you can get all that stuff. It's a lot of it's standard off the shelf stuff too that you don't even necessarily need to get through OmniTurn. Don't think I'm really missing anything. I should also mention on the control to add, this also does have a graphic display to, oh, let's see, that wrong button, sorry. Let's escape out of this. So you can also see your part being made if you want to. Nope, yeah. Just a sec, I keep hitting the wrong button here. So that gives you an estimated part cycle time. The current part I'm making 41 seconds. Then we continue through. This gives the tooling. I got 4 tools on here right now. This plate, I don't have the plate very full. It can actually handle quite a few more tools. I got them spaced pretty wide. But for this job, that's what I have on there right now. So you can put it in slow motion here. You can also put the, you know, the program in single block or slow motion or full speed. This will just show you. Now, this thing doesn't have the fanciest of graphics. In fact, this looks a little small here. You can enlarge this. You can zoom in. But it's giving me the little tool paths we're going to go through. Each tool is in a different color. Now this may look a little foreign to you, but trust me, I realize the one knock against OmniTurn is the software is a little outdated. And I agree that it is. You know, it doesn't have like real fancy graphics or anything. But you got to remember, if you're into machining, this does everything and more that machines with fancy graphics do. So if you can get beyond the fancy graphics, you want a machine that'll make aerospace quality parts, which the OmniTurn will, This will, like I said, hold tenths. You can program it down to the tenths. And I should say tenths of 1,000. So 0.0001. But it'll also hold that. I find it holds it no problem. Reach in, oh sorry, you're gonna open up, reach in, do your, okay, I didn't know if we're on the...
We're fine, calm down, don't do your dad's spaz thing.
Okay.
My God.